Today we're talking about special products of algebraic expression. So there are certain things you could memorize that'll make your life easier. Here's where I'm getting at. Last time we talked about using the distributive property when you have something like a plus b times x plus y. And we saw that the answer was a times x plus b times x plus a times y plus b times y. So, and there were a lot of things to combine to arrive at your solution. There are certain special products, hence special products, that if you memorize them, it'll make your life a lot easier. The first we're going to talk about is perfect squares. Now, perfect squares can show up in the form of a plus b squared or a minus b squared. I'm going to go ahead and do the work out the long way, and then hopefully you'll see the shortcut here. So a plus b squared means we have a plus b times a plus b, which, if you remember the distributive property from last time, means we have a times a plus b times a plus b, which means we have a times a, which is a squared, a times b, which is ab, b times a, which is ba, or I can also rewrite, for the sake of convenience, as ab and b times b, which is b squared. Now, as we go to combine our like terms, we'll notice here that I have two ab's. So I can combine this to get me a squared plus 2ab plus b squared. And if I do this with a minus b squared, then just following the same pattern before, that means I have a minus b times a minus b, or a times a minus b, minus b, it's been a while since we've dealt with subtraction, times a minus b, but don't be afraid, it's the same. So we have a times a, which is a squared, a times a negative b, so that's going to be minus ab, negative b, don't forget the operation in front over here, negative b times a, which is a negative ba, or I can rewrite to match up over here as ab, and then a negative b times a negative b, which gets me a positive b squared. Combine my like terms, and I see that I get a squared minus 2ab plus b squared. So hopefully we see the similarities here when dealing with perfect squares. You'll notice I have a positive a squared, a positive b squared, a positive a squared, a positive b squared, same thing. The only difference is this middle term. And you'll notice that middle term is always twice, because I have two of those AB values, always twice as much, because I have two of those AB values. The only difference is that if I have a negative here, I have a negative in my answer. Those are perfect squares. Now the next special product is known as a difference of squares. And you'll see why it's called a difference of squares in just a second. Let's go with purple. Okay, so I have a plus b times a minus b, which means I have a times a minus b plus b times a minus b. So I have a times a, which is a squared, a times a negative b, which is a negative ab, positive b times a, which is a positive ba or a positive ab, reordering just for convenience, and then a positive b times a negative b, which is a negative b squared. Now I'm going to combine my like terms, and what we'll see is that I have a negative ab and a positive ab. Those two terms cancel out. Here's a hint. All right, so what I'm left with is a squared minus b squared. A difference, right? Difference meaning subtraction, of squares. A squared, b squared. So what we'll see is whenever we have a term set up as a product of expressions set up as a plus b times a minus b, the resulting answer is always going to be a squared minus b squared. Always, 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 always. And the same thing with perfect squares whenever they're set up as a plus b in parentheses squared or a minus b in parentheses squared. My resulting answer is always going to be a squared plus or minus, depending, 2ab plus b squared. Let's take a look at some examples to make sense of that. So here I have 4t plus 1 squared, so that follows the format a plus b squared. It's a perfect square trinomial. My answer is going to be a perfect square trinomial. So my answer is going to look like a squared plus 2ab plus b squared. I know that because I know that's my shortcut from here to here. But let's go ahead and do the math with this actual term. So I have 4t plus 1 squared. That means I have my first term, 4t, is my a term, that's squared, plus 2 times my a term, my first term, which is 4t, times b, which is 1, plus b squared, so my second term, which is 1 squared. So then all I have to do here is the work. 4t times 4t is 16t squared, and 2 times 4 is 8, 8t times 1, so 16t squared plus 8t, plus 1 squared, which is 1. So my perfect square trinomial results in 16t squared plus 8t plus 1. I can go ahead and do this again with 6 minus n squared. So this follows the format a minus b squared, which I know is going to be a squared minus 2ab, that middle term is a negative, plus b squared, that last term is a positive. So I have 6 in parentheses squared minus 2 times 6, which is my a term, times n, which is my b term, plus n squared. So 6 squared is 36 minus 2 times 6 is 12 times n minus 12n plus n squared. And now again I have another perfect square trinomial. So notice, because you have a shortcut of a minus b, you don't have to worry about multiplying positive or negative, expanding this out, you know, going 6 times n times 6 minus n, sorry, I said minus, which means I have 6 times 6 minus n times 6 minus n, etc., so on and so forth. I don't have to worry about that because I have a shortcut, a handy-dandy shortcut, which allows me to get from one end to the other just by inputting values. Math is pretty cool that way sometimes. Last example here is we have a difference of squares. Notice this follows the format a minus b times a plus b. It's okay if they're in a different order. Doesn't matter. Don't be afraid. So remembering that everything needs to be multiplied by everything else, I know that the shortcut is going to get me to a squared minus b squared. So why don't we go ahead and use that shortcut? I have 5x, that's my a value, squared minus b squared, which is 9y. So I have 5x squared, which is 5 times 5, which gets me 25. And don't forget to square the x, 25x squared minus 9 times 9, which is 81, y squared. If you don't believe that my answers are right, you can go ahead and use the distributive property, do it out the long way, use long multiplication, whichever you like, but realize that you will end up with these similar answers. Now, here's where it gets really cool. You can use special products of algebraic expressions to evaluate the following number. I'm going to let you stew on this for a while. Know that the right way to do this is not going to be 198 times 198 to get my answer, but instead you are going to use one of these special products, whether it's a plus b squared, a minus b squared, or a plus b times a minus b, to come up with the solution. And we'll talk about that in class tomorrow. A little hint, you're going to use a minus b squared. Mwahaha.